Homework M1, question 5. This is a differentiation question where we've been given a sketch of a curve. The equation of the curve is y equals e to the x root 3 sine 3x, and we've been asked to find the turning point. We are asked to give our answer as a multiple of pi. To do this, we need to use the product rule, which is dy dx is v du dx plus u dv dx. So u is my first term, ex root 3, and if I differentiate that using the chain rule, I get root 3 e to the x root 3. V is equal to sine 3x, and again using the chain rule I get 3 cos 3x. So if I plug these values into the equation that I've got above, then I get sine 3x times root 3 e to the x root 3 plus 3 cos 3x e to the x root 3. When I'm finding the turning point, I can set dy dx equal to 0, and once I've got that set equal to 0, I can divide all my terms through by e to the x root 3, and this leaves me with 0 equals root 3 sine 3x plus 3 cos 3x. Now, if this value here was anything other than 0, I would be needing to use some of my trig rules like r cos x minus alpha or r sine x plus alpha to rewrite this problem and be able to solve it. Because it is set equal to 0, I can just rearrange it, get my cos terms on one side, my sine terms on the other, and work from there. So, minus 3 cos 3x is equal to root 3 sine 3x, or with a bit of rearrangement, tan 3x is equal to minus root 3. And if I solve that using a calculator, 3x is equal to pi by 3. There are other solutions, but because I'm only going between pi by 3 and minus pi by 3 and the point P is clearly positive, I don't need to find any more of them. And so x is equal to pi by 9. The question has only asked for the x coordinate, so I don't need to find the y coordinate here. In part B, I'm asked to find the equation of the normal to C at the point where x equals 0. So I want to plug x equals 0 into my equation for dy dx. Now this is before I eliminated e to the x root 3, so I do need to plug my value of x equals 0 into that. Fortunately, e to the power of 0 is just 1, so it's going to become 1 rather than being eliminated this time, but I don't really need to worry too much about it. Dy dx therefore is equal to root 3 times sine 0, which is 0, plus 3 cos 0. Cos 0 is 1, so dy dx is equal to 3. That's my gradient of my tangent. My gradient on my normal is minus 1 over 3. I also need to know the y coordinate. So at x equals 0, y is equal to e to the 0, which is 1, times sine 3x, sine 0, which is 0. So I got my coordinate x equals 0, y equals 0. Y minus y1 equals m x minus x1. And all that requires is a little bit of simplifying to y equals minus a third x for my final answer.